I am Anil Kumar. Welcome to my series on trigonometry. We have taken up 3 questions here for exam review. All these questions should be done without calculator. I would like you to pause the video, copy the questions, answer them, and then look into my suggestions. The questions are: three sides of a triangle ABC are AB equals to 6, BC equals to 7, and AC equals to 11. Find exact value of sine A. Question 2. A triangle ABC, AB is 6, BC is 5, angle A is 45 degrees. Find exact value of cos C, where angle C is an obtuse angle. Question 3. Given angle A as a reflex angle and cos A equals to minus 2 square root 2 over 3, find exact value of sine A and tan A. So let's look into these solutions one by one. Question number 1. Three sides of a triangle ABC are given to us. So let us sketch the triangle itself. So let me make a general triangle here. So let's say that's the triangle with given sides. Let's say the vertices are A, B, and C. The length of the sides given to us is AB is 6 centimeters, BC is 7, AC is 11. So in the given triangle, we know three sides, correct? So we know three sides. So it is SSS. So wherever three sides are given to us, we can use cosine law to solve. Perfect. We are interested in definitely finding angle. We are interested in exact value of sine A. So this is the angle we are interested in. Let's find the cosine value first, since it is a case where we can apply the cosine law, right? So you'll find the cosine angle first, cosine law or cosine rule. So we can find cos A. Cos of A will be equal to what? These two side squares, add them up, 6 square plus 11 square minus 2AB, 2 times 6 times 11 over, sorry, this 2AB comes in the denominator, minus C square, 7 square, minus 2 times 6 times 11, correct? So that becomes the value for cos A. We can do our calculation. 6 square is 36 plus 121 for 11 square minus 49 over, let's keep it as such, 2 times 6 times 11, since some numbers can be cancelled. So we have cos of A as equal to what? So let's add these two first. 121 plus 36, 7. 2 plus 3 is 5. 157 minus 49. It's better to go in smaller steps. Okay. So 7 take away 9 is 8. We borrowed 1, so we get 0 here. 108 over 2 times 6 times 11. Now 108 is a multiple of 12, which is 2 times 6 is 12. So that goes 9 times. So we could write this as equal to 9 over 11. So we get the value of cos A. But we are interested in finding sine A. How do we do that? Well, we know cos A, so we'll make another triangle here. Let's make another triangle here. We know that the value for cos A is 9 over 11. That means that this side is 9, the other side is 11. We can now find the opposite side using Pythagorean theorem. So it is square root of 11 square minus 9 square, correct? which you can calculate. So let's do this here. So 121 minus 81 square root, and that is what? 0, 4, 40 square root. So you could always write 4 times 10 or 2 square root 10. So we get this side as equals to 2 square root 10. And now we can write down the value for sine of A. So we can say sine A is basically equal to the ratio of opposite to hypotenuse, which is 2 square root 10 divided by 11. The same as what we had for sine, cosine, right? So hypotenuse remains the same. So we get our answer for the first question, which is sine of A is 2 square root 10 over 11. Is that clear to you? So that is how we are going to solve such a question. I hope the concept is absolutely clear, right? So we basically found cosine of an angle, then we constructed the triangle, right triangle, and from there we found the ratio opposite over hypotenuse for sine. Now let's take the second question, which is in triangle ABC, AB equals to 6, BC equals to 5, angle is 45. Find exact value of cos C, where angle C is an obtuse angle. Let's again construct a triangle here. Angle A this time is 45. So let's write down ABC. Angle A is given to us as 45 degrees. Side A to B is 6, B to C is 5. And we need to find the value of cosine C, where angle C is an obtuse angle. That means what? It really means that we are given this side, and angle. So we are given in this case side, and angle. So we have a combination of opposite side and angle. We can apply the sine law. Clear? But we could have an ambiguous case. That means we could have another triangle which could be kind of like this, where this side is equal to 5. And so we do have an obtuse angle C. Only then we could actually find solution of this particular question. Does make sense? Correct? So basically, as you can see in this case, that will be an isosceles triangle. These two angles will be equal, and that will be 180 degrees minus angle C, this angle, right? So both are, you could treat this also as C. So we call this as C prime now, right? Since we are interested in obtuse angle C. Does make sense to you? Correct. So that is the scenario. Let us see if sine law can help us find the answer. So we'll apply the sine law and check. So what do we get? We want to find this particular angle, let's say sine C. So we'll say sine C over the side opposite, which is 6, is equal to sine of 45 degrees over the side opposite, which is 5. So sine C is basically equal to 6 over 5, and sine of 45 degrees is square root 2 over 2. So that gives us 3 square root 2 over 5 as our answer. So that becomes the sine C. Now clearly the value of sine is positive in both the quadrants, quadrant 1 and also in quadrant 2. So that means that we have an angle here and also in this side. So we are looking for an obtuse angle. Clearly that becomes the angle of our interest. However, in the second quadrant, cosine value is going to be negative. Apply the cost rule, right? So sine is positive in quadrant 2. However, cosine is negative. So we expect negative answer for cos of C. Is that clear to you? Right? Okay. Now, how do we find cos of C? Well, last time we constructed a right triangle. Again, let us again construct a right triangle. So we'll make a right triangle for sine C. We know that this time sine ratio is opposite 3 square root 2 over 5. So that is how you could make a right triangle. You can find the adjacent side. So let's call this as let's say PQ. So let's find what is CQ equals to. CQ will be square root of 5 square minus square of 3 square root 2, which is what? Uh, 3 square is 9, 9 times 2 is 18. Okay, so CQ is basically equal to square root of 25 minus 18, which is square root of 17. 7. Okay, so 25 minus 18 is square root of 7. So this side is square root of 7 for us. And therefore, we can now write down what is cosine of C, correct? So this side is square root 7. And now we know what cos C is. So we can say cos of C will be, because it's an obtuse angle, negative, and adjacent side square root 7 divided by hypotenuse of 5. We are actually looking for it in quadrant 2. So we get our solution, which is right there. So I hope that is clear, right? So these examples are good to review the concepts which you've learned for any angles, right? Now here is the last question, which is given angle A as a reflex angle, find cos A. So when I say reflex angle, it means what? It means it's greater than 180 degrees. So we are in quadrant 3. Now in quadrant 3, cos is negative. So apply the cos rule. We know cos is negative. So we are saying cos of A is given to us as minus 2 square root 2 over 3. We need to find sine and tan. Well, tan will be positive and sine will be negative. So from the given value, as we did in the last case, let's make our triangle. So in this case, the triangle may look like this. Adjacent side being 2 square root 2 and hypotenuse being 3 for the angle A. Let's call this as P and Q. So now, what is PQ equals to? So PQ will be square root of 3 square minus square of 2 square root 2, which basically is 9 minus 2 square root 2, means 4 times 2, 8. And that is 1. So this side is 1 for us. Now knowing the sides, and we know we are working in quadrant 3, right? And that is important. We have two things. One is the magnitude, and the other thing is whether it is positive or negative. So as far as sine is concerned, sine of A is going to be negative since we are in quadrant 2. And the value will be opposite over hypotenuse, which is 1 over 3. And as far as tan A is concerned, it is going to be positive and is opposite over adjacent, which is 1 over 2 square root 2. Correct? So that is how you could get your answer. Well, you could rationalize this, multiplying by square root 2. So you get square root 2 over, when you multiply this by square root 2, you get 2 times 2 is 4. So you could write that as your answer, but with a positive value. So I hope that makes sense, correct? So these are the answers for question number 3, sine being negative and tan being positive, square root 2 over 4. Perfect. So that gives you the solution of all the 3 questions which we have taken in this particular example. Now the beauty of these questions is that we began with a condition where the cosine law can be applied, right? So we had a case of side, side, side. So that means cosine law. But what do we need to find? we need to find the sine value. Do you see that part? The second case was that we were working with side, and angle. We were working with side, and angle. So in this case, we applied the sine law. However, we were interested in finding the cos value, and that too of an obtuse angle. That means there was an ambiguous case. And the third case was actually relatively simpler, since we were working with reflex angle. We just applied the cos rule, and since we know that we are in quadrant 3, tan is going to be positive, sine and cosine will be negative. So that helped us to get the right answer. And in all the three examples, we also used the Pythagorean theorem to find the third side. So I hope that helps. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.